Good. Um, okay. Can you see my screen? First, let me confirm. Okay. So what we're going to do is we're going to have two sessions. So the first session is going to be all about introducing you to the Cali
Ferhat, I
document.
think Sylvian is raising his hand. Can you give him a moment?
Oh, okay. Okay. Yes, Sylvia.
Yes, good morning, everyone.
Good morning.
We are excited to start this cohort in partnership with the 10th Academy. So I will encourage everyone to follow all the sessions and benefit from this course as we build critical thinking and problem solving ability. And we hope it's a successful journey for everyone. So welcome.
Okay. Thank you so much, Sylvia. And with that, I think we can start. Okay. So, okay, so we're going to have two sessions for today. So the first half is going to be all about introducing you to the challenge that we're going to be doing for the first month. Which is all about data-driven decision making for relocation site selection. So I'm going to be introducing you to this challenge, work you through the scenario of the project and the tasks that we are going to be doing for the month, plus what you're going to be delivering and the data that delivery. And after that, we're going to have a session just as an introduction to data set exploration, where we're going to look at some basic ways that we can explore our data sets by using the Google Sheet, and we're going to have some short game on that as well. So what I would encourage everyone to do is to participate and ask questions. It might be related to anything. If you cannot hear my voice, please raise your hands or just open your mic and speak if you have any questions. And if you want me to go through something, again, please don't hesitate to ask. Okay. With that, I think we can start the first half of the session, which is challenge introduction to the first month, which is data-driven decision making for relocation site selection. Yes. Yes, Sylvian. Or is it anyone? Okay. Maybe it was a mistake. Okay. Okay. So let's get started. So the first thing that we're gonna look at is the scenario. So you can go through this, which is just what we'll be living in at an academy. We'll be living doing by learning by doing, which is the most effective way of enhancing employment. So that's what we're going to be doing. So we bring real world scenario to the projects and how we can tackle them or how we can do these projects by giving you tasks and a way to challenge to just deliver it. Okay, so it's going to be a 4 week duration challenge. The tutorials for each week are relevant to the tasks at hand, and we're going to have this kind of Google Meets sessions where we're going to discuss about the tasks and way to do or to just perform the tasks. So we have the schedule. I believe you all have it, and Slack where its service has pretty much the main platform for communication. So the tutorials are available from 8 to 14 UTC to respond to your queries within 5 minutes. Okay, so let's get started with the project scenario. So for this project, we're going to be working for or at a company called Preborn. So this company is planning to relocate its headquarters to Africa and requires a data-driven approach to identify which is the best city. So in order to help them identify which is the best city, they have identified three goals that they want to achieve. So your job is going to be going through these cities and identifying whether or not these cities are in line with your goals, with your company's goal. So the chosen location must align with the company's commitment to sustainability, which is the first goal, and provide a healthy and cost-effective environment, which is the second goal. Being healthy part is the second, the third goal. So since for this scenario, you're working as an operation manager, your job is to analyze environmental and economical data that we have actually provided the environmental data, and we have provided a way for you to just extract the economic data uh, to make a well-informed recommendation. That's data-driven. So the specific goals that you are going to be covering for this project are environmental quality monitoring and coverage analysis, which is just evaluating the cities based on their quality of air or air quality data, and identifying those with low pollution level or pollutant level and reliable monitoring system. So when you work with the data, the air quality data, you're going to be looking at how reliable data actually is and their pollution level. So you're gonna select the lowest pollution level. Clean air supports employee health and productivity. So we believe at Freeborn company, we believe that the cleaner the air, so the more productive they become, in addition to being healthy. So the second goal, which is sustainability and health impact, is where you assess the potential of health benefits for employees by prioritizing cities with clean air. And third, which is the third goal, is cost of living analysis. So here you're going to evaluate how affordable the city is based on living expenses, such as the housing expense, how much does it cost for an apartment, that's one bedroom apartment, transportation, the like average living cost or the average grocery and so on. So we're going to be looking at those as well. So yeah. So in short, the business problem statement is your company, which is Freeborn Inc., is facing a crucial decision. They need to make this crucial decision in selecting a sustainable and affordable location for its headquarters. Data-driven decision making is essential to align the goals with health, which is the first goal, sustainability, which is the second goal, and cost efficiency, which is the third. Okay, I think someone has their mic on. Is that a question? Boris? Boris? Maybe it was an accident. Okay. So at the end of this project, at the end of this project, the expected outcomes are use data analysis tools to assess the quality of the air monitoring system, learn how to implement data visualization by using Google Sheets, and building your dashboard by using Google Studio, and by using Google Sheets, you will acquire skills to present complex data visualization, embracing clear communication. So that's how you're going to be communicating your insights and insights into your data things. And dive deeper into the data analysis using the advanced features of Google Sheets, where you will explore about data analysis methods and synthesize learning and present your project outcomes, where you will learn how to report by exploring the technique of summarizing and reporting project results and progress by using RBM principles to stakeholders through structured presentation. And of course, master the generative AI tools for reporting and creation, for report creation and fast delivery. Okay, so with that, let's move to the data set that we have provided to you, so which is the air quality measurement data. So you can actually find this data on Kaggle here. If you go to this link, you can find this data. Yeah, so Africo AirQO Africa Air Quality Prediction Challenge. So it was a challenge on cargo. You can go through this and take a look at some of the details here as well. But we have extracted it and provided it to you. So you don't have to go through it. But if you like, you can. So it includes four countries which we have, which are presented. So Uganda, Kenya, Nigeria, and Burundi. So the data that we have provided here, you can see it's in a spreadsheet. So we have the hour, the month, the site ID, the latitude and the longitude of the city, the site, the city, the date, the country, the sulfur dioxide, PM2.5, nitrogen dioxide, carbon monoxide, and ozone. So here are the data that we are going to be working with. Okay. So just to give you an insight about the features or the elements of the data that we have provided. So hour represents the hour of the day where the measurement was taken. So it ranges from 0 to 23, uh, representing each hour. Month indicates the month where when the measurement was taken. It ranges from January to December, so 1 to 12. And the site ID, which is a unique identifier for each site, it will actually help you distinguish between different measurement locations, even if they are in the same city. And the latitude and the longitude just give you the coordinates, the exact coordinates of the measurement sites, the cities where the measurement site is located, the dates, and the country is also the country where the measurement site is located, the dates when the date when the measurement is taken. Sulfur dioxide is the measurement of the date, how dense of the sulfur dioxide is in the atmosphere. And PM2.5 is the concentration of particulate material, which we call PM2.5, which are actually used by WHO in order to test how clean the areas. And these are tiny and can't penetrate deep into the land. So they are really bad guys. Okay, and cause various health issue. The nitrogen peroxide yeah, represents this, the density of nitrogen peroxide in the atmosphere, and carbon monoxide, of course, major studies of carbon monoxide in the atmosphere. And ozone, or also major studies of the ozone atmosphere. So this is just a highlight of what's represented or what's presented in the data. And for the team, we have Yatabal, who's the head instructor, and Malik Tayi, who you met earlier, who's the lead tutor, and we, including four other technical tutors, will be in this, will be available or in this program. So the key dates include two. So child introduction, which is today, actually yesterday was for the other section, sorry, and today. So today is going to be the child introduction for you guys, and the final submission, which is going to be immense. Okay, so before we start with deliverables and tasks to be done, where we discuss in depth of how we can tackle this actual challenge. Do you have any questions? I would like to give the floor to you guys, back to you guys. So if you have any questions, please ask. If you don't, you can just show me some thumbs up and we can continue.
Give a thumbs up. Raise a hand. Raise a hand.
Yeah, okay, good. I believe it's clear. So it's continuing then. Okay, so we have classified that as a whole project into tasks in order to help you achieve this. So the project overview is just an overview of the project which we have done. So let's dive into the task. So the first task that we're going to be doing is, so each task, before I start, each task has their own deliverables where you are, yes, Kevin. Kevin, is that a question? Okay, maybe it was not. Okay. Yeah. Uh, so each task, as I was saying, each task has their own deliverables and their own step that you can follow in order to achieve them. So the first task is going to be data and problem understanding, which is all about understanding the data and understanding the problem and what's at hand. So the first step is going to be, of course, exploring the data set, with which actually is the first step in any type of, or in any case of data analysis. So understanding the data, you're gonna be looking at the pollutant level, which you can find by doing some statistical measures of finding the average, the maximum, and the minimum of the pollutant level for each city. And also you can sort the data by city that identifies the trend. So we will actually see how can do this in temporal trends, just to create, we look at the pollution level across different hours and must identify the seasonal pattern. So you can actually consider this to be time series data. By creating a time series data, you can actually see which city has a constant pattern, or pattern that repeats itself in the trend. So the question that you're going to be answering here are these cities with constantly stable, are these cities constantly stable, have constantly stable pollution level. So by looking at the trend, you can actually find out if the pollution, or the pollution level, is stable across the months or the year or the hour. And the second step for task one is going to be connecting the data with the business context, or the business understanding, or you can say the problem statement. So here, what you're going to do is you're going to answer these questions to prepare for analysis. So which point are most relevant to for health and sustainability goals? So we have actually seen around 4 or 5 pollutants measurements. So which of these is the most toxic, or the most relevant to health, and which one is the least? So you can actually rank them. Which cities show the lowest average pollutant level, and how does the data reliability? Or so if you have low number of data points, or if you have low number of monitoring sites, you could actually have a hard time building confidence on your analysis, because you cannot be confident in how repeatable that data is. So that's what we're going to be doing here. So how does the data reliability affect your confidence in the analysis? So the more confident, the more data points, or the more data you have, the more uh, confident you can. So we do encourage you to use LLMs, or models, ChatGPT and Gemini, in order to help you with this project. So here are some prompts that will help you to get started uh, with this project, with this task actually. So in order to learn the air quality basics, so just you can just explain the health impact of pollutant, like PM2.5 and nitrogen carbon dioxide, or the carbon monoxide and so on, and just see the results, understand the data attributes, and clarify the WHO standard. So what are the WHO pollution thresholds for PM2.5 and nitrogen carbon dioxide? So after you are done with this project, the learning outcomes are understanding the significance of air quality in decision making. Uh, I think there was a question here. Okay. Innocent asked, I have a question. I'm the one who finished the program. However, did not provide me with the certificate. Can you please give me clarification on that one? Okay, I think Malik is actually going to that, so I will continue with that. But Malik is going to be answering that one. Okay, so let's move to task two. So here, you're going to be on task two. You're going to be preparing and exploring the datasets, where the objective is just to prepare the air quality dataset program, uh, just to prepare the quality data set to analyze by cleaning, organizing it, and performing some EDA or explanatory data analysis process. So the first step, of course, is going to be cleaning the data. And by cleaning the data, you will be handling missing values, which is the most crucial thing in the beginning of the data, before analyzing it. So here you will first identify the missing values, and then you will choose a technique to fill these missing values. So you could choose to fill the missing values with the average of the column, or you could decide to remove the whole row if that row actually have too many missing values. So we actually have a session on that one. So we will see how we can do it. So we actually have also added some formulas that you can actually apply yourself. So if that cell is blank, you can just fill it with missing. Here, this will help you flag the missing values, and you can actually replace the missing values here. I'm using average just to fill it. So you can do that as well. And the second step, or the second cleaning technique, is removing duplicates, where you check for duplicates and remove them. So uh, the Google should actually have a built-in function that you can do it. So you just have to go to data cleanup, and then remove the duplicates. And of course, checking how consistent the data is. So here is where you identify outliers and handle them. So here you will ensure the pollutant values are within a reasonable range. So P25, PM25 actually do not exceed 500 milligram per meter cube. So if you find it, you have to flag it and remove it, or otherwise use another technique in order to handle it. So with this, so here, if and values greater than sorry, greater than or equal to the minimum value, and if the value is less than or equal to the maximum value, it's valid, and if it's not, it's invalid. So these are the conditions. So if the value is within this range, it's valid, and if it's not, it's invalid. So you have to flag it with this and remove it, or with other techniques in order to do so. So the second part is organizing it. After you clean it, you will organize it. So you can organize the data by creating a summary table or a pivot table. Here you can calculate the average, the minimum, the maximum pollutant level for each city by using the pivot table to summarize. So how you can just insert a new pivot table and rows, identify the rows, or select the rows as cities and the values, or the pollutant labels, which are PM25, sulfur dioxide, nitrogen peroxide, and carbon monoxide, and ozone, of course, in the values, and identify the average, the minimum, and the maximum level for each city. And of course, you can also add derived column, so you can just put these with labels together and create a column for that's called air quality index. So this is a recommendation. You can use it by using the data. So here is just a simplified formula for that one as well. We will also see how we can do other tasks. Okay, before we move on, do you guys have any questions? Is my sound clear? Are you guys hearing clearly? Just have to confirm that. Okay, I will take that as a yes. So for step 3 of task 2, you're going to be working with exploring the pattern of the data. So here you will visualize the temporal data in the temporal trend, where you will create just a line chart to show the pollutant level at each, how they change over each month or each hour. You can change choose to do that and highlight the cities with significant seasonal variation. So does actually data or the pollutant level differ higher, slightly higher with the season or not? You can add it right here. So here is how you can do it. So you can select the month and the pollutant element and insert a line chart from the toolbar. And then you can also compare the cities by using bar charts in order to compare their pollutant level and compare them across cities, different cities. And how you can do this is actually also with here. So you just plot the cities on x-axis and their pollutant level on y-axis and use different color for each pollutions or pollutant, and you can identify it, or it's easier for you to uh, see their rank. And of course, the last step for this is going to be assessing the monitoring reality and to see how many site IDs the city have, because the more this monitoring site that the city have, the more reliable the data is. So here also you can use a pivot or a quick summary table in order to count the number of sites per city. And also we have included some prompts in order to help you get started with this task as well by using ChatGPT and Gemini. You can, sorry, you can actually get started with them. So in order to clean the dataset, you can just ask it how do I find and remove duplicate rows in the Google Sheet and so on. So here you can follow these steps, or you can just use these prompts in order to help you get started with this task as well. So at the end of the task 2, so what you're going to be delivering, or what's the outcome is going to be a clean data set. So we have already provided, actually, we have seen this, I am showing you this data set. So it is not clean. You can see a bunch of like non-values or details. Yes. Is that a question? Empty cells. So yeah, on task 2, you're gonna be like cleaning this data set, and you're gonna be providing us, or you're gonna be submitting the updated and cleaned data set in Google Sheet as well. So I don't believe you can work on this sheet. So just go ahead and make a copy of it and start working on cleaning your own copy of the dataset, and you're gonna be submitting the updated and clean version of the dataset. And of course, a summary table, which includes a keyboard table showing average pollutant level by city and different visualizations, which include a line chart to show the trend or the pattern, which we have seen as the important trends, and the bar charts, which is going to compare the pollutant level across cities in order to help you run them. And a short reflection, which is just a summary, a quick summary about which city appears to have the cleanest air, and idea significant seasonal patterns in the pollution level, and how reliable is the data. And the outcomes, of course, are gaining experience to scale and preparing data set, real world data set, and learn how to summarize and visualize this data and identify the preliminary insights into which the city aligns the company's goal, which is the basically the main thing in this project. Okay, so moving on to task 3. So Here you're going to be analyzing the living cost or how affordable the city really is. So in order to help you do this, you're going to be collecting the costs of living by using AI, or as actually we have provided an additional two sites which you can use to cross-check and see how reliable the source is. So here are the steps or the key expenses or categories that you need to identify primarily are the housing. Where, for example, you can just look for how much is spent for a one-bedroom apartment. Transportation, the average monthly public transport pass, the utilities, which include electricity, water, and internet, and groceries, which is just the average monthly cost. And of course, you can use AI tools to help you gather this data. You can use ChatGPT and Gemini since they already have a built-in web search. So you can just ask it what is average rent for one bedroom apartment, Kigali, and so on. So here you can actually use these two sites in order to validate and cross-check how reliable the online sources. So here, these two sites, this is one of the sites that we have provided you with. So here you can actually see how the average rent or cost the city have. So for instance, we can use, let's say, Rwanda, maybe. Um, so here is just uh, an overview or the average of the cost. So here you can see that the measurement or the currency is actually Rwandan. So you can actually change this into, yes, just dollars and see how much it costs. So meal in an expensive restaurant is actually $2.53 and so on the market. Sorry. Um, so transportation, utilities, child care, clothing, rent per month. So apartment for one year bedroom in the center of the city is actually $382. So these are one of the sites that you can look for the data as well. Okay, so after you collect it, you will organize the data by creating a table summary for each city and make sure to convert all the costs into United States dollars in order to have a standard. So if, for instance, for Ethiopia, if you collect it in Ethiopian birr, and for other cities, if you collect it by using their currency, you will have actually a hard time comparing them. So make sure to convert them. Actually, I believe that we should actually have a built-in function that you can use in order to convert it. And then analyze how affordable they are, and finally you can rank them based on how affordable they are and what you're going to be submitting for or delivering for these uh, like for task three are a summary table of cost of living data, a brief reflection on how living cost impact the decision making process. And for task four, an in-depth data analysis, which is just perform a detailed analysis in cleaned on the clean data set to extract actionable insights in order to help you identify which city has the best quality, air quality, which is sustainable and which is inexpensive to live in. So here, for step one, you can start by analyzing the city's level of pollution. So here are calculation of overall pollution score. So priorly on the first task, we have seen how we can identify which pollutant actually is more toxic or is more, I would say, would have a more impact on health. So based on that data or data analysis, you can actually give them weight. So here, according to this formula, 0 0.4 is given for PM2.5, which means PM2.5 is more toxic or have more impact on health, and 0.25 is given to carbon dioxide, and 0.25 is also actually given to the nitrogen dioxide. So this means that these two pollutants have actually similar or equal level of impact, and zero point 0.1 for carbon monoxide and or the ozone. So assign higher weights for the more critical pollutants like PM2.5, and then rank the cities according to their rank by by using this formula, you will have a score, and based on that score, you can actually rearrange them or rank them. So after that, you will identify the top three cities with the lowest pollution score. And of course, the second one is explore temporal trend. So as we have discussed earlier, some cities might have a low pollution level or a low pollutants reading on some month and a higher on the others. So in order to validate this, you will see the seasonal variation. So group them by month and see how each pollutant level change across the month. You can actually use a
Yazongera
filter for
kuyikora.
this one. Uh, yes, Oliver, is that a question?
Yazongera sigana strike ngo nyakaba.
Oliver, Oliver, is that a question? If not, can you mute your mic, please? Okay, good. And of course, the second one is our hourly variation. So this will help you see or identify if the pollution level actually rise or peak at business hours, which will actually impact your productivity or the employee's productivity. So you need to actually look into that as well. So you can use heat map in order to see or in order to highlight the hours and with their highest pollution level. So if the pollution level at business hour is higher for that city, it means it could impact the productivity of the employees. So you have to check that as well. So what you would extract from doing this step two is determining certain cities have consistent air quality throughout the year and identify cities with low pollution during business hours. Okay, so the third step in this uh, task is going to be evaluating how reliable the data set is. The data are. So here you can check the monitoring coverage. So you can count the number of monitoring sites and see how many sites are there for the city. The more the sites, the more reliable the data is, and the more confident you will become in your analysis. And detect data gaps. So if let's say a certain city has more missing values or missing rows and or are inconsistent reading in the temporal data, that could actually make it not very reliable. So the insight you can get from this one is highlight cities with strong monitoring system and complete data. And for the first step, you can correlate the pollution with employee level. So WHO actually have a guideline to just classify the pollution level. So for PM2.5, low is actually lower, less than or equal to 10 milligrams per meter cube, and moderate actually is actually in between 10 and 25 milligrams per meter cube, and high actually indicates the pollutant level of greater than 25 milligram per meter cube. So how count how many days each city stays within the low, stays within the moderate, and stays within the high, in order to see if that city is fit for the campaign score. So the insight that you get from this is going to be highlight the city with the least health impact based on their threshold. And what you're going to be delivering for this one is a pollution score table, which is just a table ranking the cities by overall pollution score, and a line chart for seasonal trend, and a heat map for hourly pollution pattern for visualization, and data reliability table, which is just a summary of showing how many, the number of monitoring sites, and just way is table. That's going to summarize the data completeness for each. So how many how reliable the data is. And health analysis summary, which is just a report to identify the cities with low health risk based on the WHO pollution threshold. So here we have identified three thresholds. So based on this, we can identify or summarize your findings. Is that a question, boys? So every time you open your mic, I'm going to assume that there's a question. Boris? Boris, is that a question? If not, can you mute your mic? Okay. Boris, can you mute your mic? Thank you. So the learning outcomes include conducting advanced analysis to extract meaningful patterns, understanding the relationship between the pollutants, temperature and health impact, and evaluating how reliable the data is in order to help you make a sound decision. And then after you do all the analysis and you get the idea of which city is more healthy and more reliable to live in or affordable, you can go ahead and build a dashboard by using Google Data Studio in order to help you show or communicate your insights with stakeholders. So in order to help you do this, we have included a couple of some just steps. So the first is prepare the clean data set, verify the data set is ready to integrate since both Google Sheets and the Google Data Studio are in the same ecosystem. You can actually integrate them seamlessly. So that's a good thing. And then you're going to collect the data set into the Google Data Studio. Here is the step on how you can do that. And you can just select the cleaned version of the dataset here and start building your dashboard. So in order to help you build your dashboard, you can add key visualizations such as bar chart in order to help you compare the pollutant level across each city, line chart, which is going to show the seasonal trends in pollutants, and scatter plots, which is going to help you show the correlation between the pollutant score and affordability score. And table is a heat map, which is going to help you highlight the cleanest city and those with stable pollution level. After you add these key visualizations, you can actually go ahead and make the dashboard interactive by adding a data range picker that's user or the end user can use in order to interact with data directly, and include a filter in order to allow the user to focus on a specific city or on a specific pollutant. So we're going to see how we can do that as well. So yeah, and also use updated feeds in order to create a new matrix. So we have seen this weight in order to help us identify or create a score. So just create a new matrix called pollution score and keep the formula that we see fit, and we create a new. And of course, just as a last step for this task is going to be style and organize the dashboard. So the dashboard needs to be more interactive or and more visual appealing. So make sure to apply consistent color for city and scores, and add titles and annotations and arrange the charts and filter very neatly for a professional output layout. So what you're going to be delivering for this task is going to be screenshots of captured by capturing a clear screenshot for each key visualizations and make sure that screenshots are labeled and they explain what they are showing. And you can actually copy and paste these screenshots into your report, and under the section, make sure to add a title such as dashboard visualizations and add a brief caption message that can capture what the visualization is actually showing. So here, for example, a bar chart comparing the full-time level across the cities. Okay, we are on the couple of actually tasks. So the final recommendation is just synthesizing the insights, where it is where you synthesize your insights. You bring all the key findings from previous tasks from a holistic view of each city and answer, develop a recommendation by answering these questions. So which city balances good air and affordability, and of course, hence benefits, and are there any trade-offs? So by this we mean, so some cities might have a lower lowing cost or I'm sorry, a lower living cost, but a higher pollutant level or a lot higher pollution level and a higher cost. So there might be some trade-off between these things. So you will actually need to answer that one as well. And how does the recommended city align with your company's system goals? And of course, you need to actually recommend an action. So suggest how your company can address potential challenge, such as mitigating health risk is pollution is moderate. So, so if the city that you have identified or selected has a moderate pollution level, how is the company going to mitigate the health risk due to that? And of course, you need to prepare a final report, and we have actually introduced or included a structure. So introduction, methodology, findings, recommendations, and of course, conclusion. And what each section represents actually is included here. And of course, you need to include visuals as well. So so we have also included some prompts that example prompts that you can use to in order to help you draft your reports. You can also follow these prompts in order to help you get started. Okay, and what you're going to be providing us or delivering for task 6 is going to be a PDF. So please make sure that the project or the report that you're going to be submitting is in a PDF format. And this PDF document is going to be showing your findings and the recommendations. So the learning outcomes, of course, include the synthesized data from multiple analysis and into actionable insights, develop a professional report writing and presentation for decision making, and building confidence in data-driven decision making and communication. Okay. So that's it for the tasks and what you're going to be delivering. So for the due dates, so you're going to be only having one submission, which is going to include all of the tasks, basically from task 1 up to task 6. And what you're going to be submitting is a report in a PDF format. And the objective is just the final submission requires you to synthesize their full project work, which is going to showcase their ability to use AI tools in order to accelerate their and improve their data visualization in the report. So we do require the document or the report that you're going to be submitting to be in a PDF format and to have a minimum page of 3 and a maximum page of 10. And of course, the content of the report, we have actually included it here. So the executive summary, it's better to start with an executive summary, which is just a one paragraph summary of what has been presented or what's going to be presented in the report. And some just data analysis and final visualizations. You can actually provide links and screenshots in order to interactive dashboards that we have created in Google Data Studio, along with an explanation of how they can be used by the stakeholders, and of course, a recommendation, which is basically the whole project. And conclusion, which is going to help you summarize the report in the next step that's you're going to take. Okay, that's it for the project, and we do have a late policy. So we do expect you to be on time or to have an on time submission because we believe that it's crucial for preparing you guys for the professional work world. So being on time means attending the sessions or activities before the scheduled start time and submitting assignments before or on the due date. So we have included the policy here as well, so you can actually see it here. And for the tutorial sessions, so today we had the introduction and data set exploration, and next week we're going to have data handling, data cleaning, and visualization with Elias. And then the week after that, we're going to have a session on AI-driven. So this one is actually that one, but the sessions are the same, only the date, AI-driven analysis, and the Google Data Studio with Intinen, and uh, of course, the last submission or the last schedule is going to be inside communication with your project. So you will be getting feedbacks and comments in addition to a grade after you send it. Okay, so we have also included some reference that you can go through in order to help you get started with the project right away. Yeah, okay. So that's it for the introduction. Is there any question that's or any confusion that needs to be addressed? Please ask, and we can actually go through it together. Okay, no questions. Okay, if no questions, is it clear? Can you actually can you at least give me some confirmation that it's clear? You can just show me some thumbs up. You can't speak. We can continue to the next session, which is just going to be an introduction to data set exploration. Okay, I have two guys, two, uh, okay, three. Okay, in that case, let's get started with the second part of the session. But before that, since we need to separate the sessions, let me just start the recording and start it right away so that we can identify which